Industrial IoT connects sensors, controllers, machines, and cloud platforms to improve efficiency, predictive maintenance, and automation. However, this connectivity also expands the attack surface dramatically. Traditional operational technology systems were originally designed to operate in isolated environments, but today they are increasingly connected to enterprise IT networks and the internet. This convergence of IT and OT creates new cybersecurity risks. Cyber physical system security threats can be classified into three main layers. 1. Cyber domain attacks targeting software, communication networks, and data systems. 2. Cyber physical domain attacks that manipulate the interaction between computational systems and physical processes. 3. Physical domain attacks or failures affecting the physical infrastructure or environment. Let's start with some of the most important threats affecting IoT and industrial IoT systems. One major threat is botnet based attacks. Many IoT devices are deployed with weak authentication or default credentials. Malware, such as the Mirai botnet, exploited this weakness by infecting thousands of IoT devices like cameras and routers, turning them into large scale distributed denial of service platforms. Another serious threat is unauthorized device access. If attackers gain access to industrial devices such as PLCs, RTUs, or gateways, they may manipulate commands, disrupt production processes, or damage physical equipment. In industrial environments, cyber attacks can directly affect safety and operational continuity. A third threat is data interception and manipulation. IoT devices constantly exchange data with gateways, edge systems, and cloud platforms. If communication channels are not encrypted, attackers may intercept sensitive operational data or inject false commands into the system. We also need to consider supply chain vulnerabilities. Many industrial devices rely on firmware and software components from multiple vendors. If these components contain vulnerabilities or malicious code, attackers may exploit them to gain persistent access to the network. Finally, ransomware has become a growing concern in industrial environments. Attackers target manufacturing plants, energy systems, and critical infrastructure by encrypting operational data or disabling control systems, causing major operational disruptions. To defend against these threats, organizations must adopt a layered security architecture for IoT and industrial IoT systems. The first layer is device security. Every IoT device should have a unique identity and strong authentication mechanism. Secure boot and hardware-based trust anchors can ensure that devices only run trusted firmware. Regular firmware updates and vulnerability patching are also essential. The second layer is network security. Industrial networks should implement segmentation between IT and OT environments. Technologies such as firewalls, virtual LANs, and industrial demilitarized zones can limit lateral movement by attackers. Network monitoring systems can also detect abnormal traffic patterns that indicate potential intrusions. The third layer is communication security. All data transmitted between devices, gateways, and cloud services should use strong encryption protocols. Secure protocols such as TLS help prevent eavesdropping and data manipulation. The fourth layer is identity and access management. Only authorized users and systems should be able to access industrial devices and data. Multi-factor authentication, role-based access control, and strict credential management policies are essential components of a secure architecture. Another critical layer is monitoring and threat detection. Industrial organizations should deploy security monitoring tools that combine IT security techniques with OT visibility. Intrusion detection systems, anomaly detection, and security information and event management platforms can help detect attacks early. Finally, organizations must implement governance and risk management processes. This includes vulnerability assessments, incident response planning, security training, and compliance with frameworks such as IEC 62443 or the NIST Cybersecurity Framework. In summary, Industrial IoT brings tremendous benefits to modern industry, but it also introduces new cybersecurity risks. By understanding the threat landscape and implementing a layered security architecture that includes device security, network protection, secure communication, access control, and continuous monitoring, organizations can significantly reduce their exposure to cyber threats. Cybersecurity is no longer optional for industrial IoT systems. It is a foundational requirement for building resilient and trustworthy industrial operations.